Hey guys, this is the video on how to properly implement the servo mapping. So I'll go ahead and show you how to go from getting the Maestro values and putting them into another piece of software, and then finally putting them into the GUI code. So first, you should have already gotten this from a previous video. You'll have this, you'll open it up, and then you'll have dithered this to find the proper target value. Once you have those, we'll go ahead and go to mapcalc.py, which is included in the GitHub repo for the antenna tracker software. In here, you'll need to go ahead to line 24. On here, this is where you'll be determining the microseconds per degree and the PWM value offset. So first you put in your 0 degrees and 6,000. So the values that you get out of the Maestro software is going to need to be multiplied by 4. And that's because the values that are actually getting output to the servos are in quarter microsecond values. So now that we've got that in there, you'll have another 90 degree, and then in this case we're just going to leave it at 4350. And this is from a previous servo that I was working with. Once this is done, you'll save the file, and then navigate to that file. So we'll do cd documents. In my case, it's saved in Python scripts, and you can see in here there's the mapping calc software. So we'll cd into that, and then we'll just do python mapcalc.py. Okay, and so you'll see here it outputs two values for us. The first one, like I said, is going to be the microseconds per degree, and the second one is the offset value. So you'll want to record those values, and then you'll do it again for this one, for the second value that you recorded. So you'll have 0 to 6,000, and then this time we'll change it to like 270, and whatever the second value was. It should be somewhere, around 7,000. So we'll just say 750. Save the file again, go back to that window, run that script again, and you got a different value. So this time we're going to record both of those, and you may want to do it a third time for 90 and 270. So we'll just say 4350, somewhere around there. And again, you'll put in whatever values you recorded. Okay, and then we save that, go back to our window here, run it again, and we got a different value. Now the values that you get will be a lot closer together than what's being displayed here. But once we've got those values, we'll go into the antenna tracker and RFD controls GUI.py file. Scroll down to around line 1763, and you'll see these pan2 values. In here, you're going to go to line 1767 to start with, and so this is for the value between 0 and 90. So when we did the calculation with the 0 value and the 90 degree value, you'll replace the microseconds per degree here and the offset value here. And you'll do that again for this line, where it's going to be the value between 0 and 270. The third one is going to be that third value you calculated, and it's going to go right here. And that's just going to be if it's any value outside of those two ranges, it'll just catch this, and so you'll have a mapping value to use in that situation. And then you'll redo this again one more time for your tilt mapping. So you'll use the values you got out of the Maestro and put those into this section right here on line 1798. Once that's done, you'll be able to save this file. And just like previous times when you run the ground station, you'll navigate to where that's at in your command line. And then you'll do Python antenna tracker, and it'll run. And it'll be right here. And so from here on out, when you go to use your servos, it'll be mapped to your particular servo. And if you're using any different servos, you'll want to replace those mapping, because no two servos are exactly the same. So once you've got those in and your input into the code, you should be good to go. And that's it. Thanks for watching.